In many instances, we would like to talk about a linear function, but we aren't actually given one. And so sometimes it's really, really helpful to be able to come up with an equation that would help describe a particular situation. So in the following problems, what we're going to do is write an equation in slope-intercept form for a linear function that meets the following conditions. Keep in mind that the slope-intercept form of an equation is y equals mx plus b, where m is the slope and b is the y-intercept. So in each of these problems, it's going to be our job to figure out the slope and the y-intercept. All right, let's take a look at our first example here. In problem 14, it asks us to find the equation of a line that has a slope of -2 and a vertical intercept at 0, 1. A slope of -2, slope is our n value. We're going to just be able to plug that right into our equation. And in this case, it gives us the vertical intercept. Remember, the vertical intercept is where x is equal to 0, and that happens at y equals 1. So that's our y-intercept. So if we want to go ahead and write our equation in this case, all we're going to do is we're going to plug in -2 for our slope and +1 for our y-intercept. Our final equation should always have both x and y still in there, so it represents the input and output for our function. So if they give us the slope and the y-intercept, writing an equation in slope-intercept form, piece of cake, just plugging the numbers into the right spots. With problem 15, however, it's not quite as simple. Here again, they tell us the slope of our line was 3/4, so we know what our n value is. When we come over here, however, it tells us that it goes through the point 2, -1. Now, that's interesting, and it's enough to pin down our equation in a unique way. However, it doesn't give us the y-intercept that we need in order to fill it into the equation of y equals mx plus b. So how do you go about a problem like this? Well, first of all, if our slope is 3/4, let's go ahead and take the time to write that in for m. Now what I have is I have another equation. It has x and y in it, but it also has this unknown value of b. The additional piece of information we have is a point that we know makes this equation true. This point has an x-coordinate and a y-coordinate. So if I come over here to my equation, I can put in this x-y coordinate pair, and that will leave me with only one unknown, just a b value, and I'll be able to have an equation that I can actually solve. So let's see what that would look like here. In this case, the y is the -1 value in my ordered pair, and the x value is 2 in my ordered pair. So I just plug those values in for x and y respectively. Now, I just need to solve for b. In each of these cases, once you've plugged an xy point in, there's going to be a multiplication that you can do. Sometimes this is going to involve fractions. Here we can put this as 2/1. We'll get a 2 in the denominator, and we can think of this as 3/2. Now, I want to finish solving for b, so I'm going to need to subtract 3/2 from each side. And that will be my final solution for b. So let's go ahead and do that. Keep in mind that we would need a common denominator here, so this is like -2/2 minus 3/2, and that ends up giving us a -5/2 altogether for my b value. Now, in a lot of cases in this class, once you've done this much work and you solved an equation, you're finished, but that's not what our problem was asking us for. Remember, our problem was asking us to write an equation of a line in slope-intercept form. So now that I've solved the equation, I do have enough information that I'll be able to do that to write that function or that equation. So again, what we do is we go y equals, we put the slope in that we were given, 3/4 x, and now we put in the y-intercept that we calculated, -5/2. And that's going to be the equation of our linear function that meets this particular description. The last type of problem that we frequently see is they don't give us the slope at all, but instead they just give us 2 points that a line would pass through. In problem 16, we're looking for the equation of a line that goes through the points 2, -4, and 3, 1. We'll go ahead and just slide this all the way up. So in this case, when we go to use our general form of an equation, y equals mx plus b, the first thing that you may notice is I don't know anything in this equation. I'm not given the slope. Neither of these points is the y-intercept, so it doesn't look at first like I have very much information that I can go on. However, we do know that if you have 2 points, so for example, the point 2, -4, and you don't have to draw this, I just want to illustrate something here. 2, -4 is right here, and 3, 1 is up here. having just 2 points is enough to uniquely define that line. So it should be enough for us to come up with an equation of that line. How do we do it? Well, they don't give us the slope, but we do have a formula to calculate the slope from 2 points. Remember, m is equal to y2 minus y1 over x2 minus x1. Here's our first point, x1, y1. Here's our second point, x2, y2. Plugging that in the formula, we're going to end up with 1 minus negative 4 in the numerator. And in the denominator, we're going to have 3 minus 2. 1 minus negative 4, 3 minus 2. When we simplify that, that gives us 5 over 1, which we can just write as 5. So now I can write my general form of an equation, y equals, my slope m is 5, x plus b. However, I still don't have the y-intercept. That said, I do know a couple of points that will work for x and y. It's entirely up to you which point you use. It doesn't matter. You'll get exactly the same value for b, which is super cool. I'm going to choose 3, 1 because everything's positive and I think that's a little bit easier to solve. But if you'd like, go ahead and go through the 0.2, negative 4 as well, and you'll see that you come up with the same value for b in the end. So if I'm going to use the 0.31, 3 is my x value, so I'm going to plug the 3 in for x over here on the right-hand side. And 1 is my y value, so that ends up on the left-hand side. I always have a set of numbers here that I can go ahead and multiply. And now I have a real simple equation I can solve for b. Right now I'm going to have to get rid of the 15, so I'm going to minus 15 from each side. And in this case, I end up with negative 14 as my b value. Once again, this is not the final answer, but it's the last necessary piece that I need. Now I can go back to the equation y equals mx plus b. I can put in the slope that I calculated, which was 5, and I can put in the b, which I calculated, which is minus 14. My final equation has x and y to represent the input and output of that equation, and I have found a problem, or an equation of this function that represents this particular situation. Couple of things to note here that I think are interesting. Keep in mind, if you put in 2 for x and negative 4 for y, this should come out as a true statement. If you put 3 in for x and 1 in for y, this should come out as a true equation. So it's kind of a nice way that you can double check your work or give yourself a little sanity check when you're done, if you'd like to make sure that your equation will actually work for the situation. 17, same exact process, and this is going to be the case anytime you have something like this. In problem 17, we're again given 2 points. We would like to write our equation in y equals mx plus b form. I do not know the slope, and I do not know the y-intercept, so always start by finding the slope first. In this particular case, or in every case really, our slope is equal to y2 minus y1 over x2 minus x1. Ooh, that. Now we'll go ahead and subtract, so it's going to be 2 minus 5 on the top, and on the bottom x2 minus x1 is going to give us 1 minus negative 2. Be super careful with those negatives. Remember, you're always subtracting because we're looking for the change or the difference in between x's and y values, and so just really watch it when you've got those negatives. Here 2 minus 5 gives me a negative 3 on top. 1 minus negative 2 ends up giving me a positive 3 on the bottom, and that reduces to negative 1 as my slope. So I can come over here to my equation, y equals, instead of m, I'm going to have negative 1 x plus b. Now I just need to pick one of my points to plug in for x and y and use that to solve for b. I'll use the 1 and the 2 here. Remember, 1 is x and 2 is y. So when I plug my values in, I have 2 equals negative 1 times 1 plus b. Negative 1 times 1 is negative 1. Bring everything else down, and then to finish getting the b by itself, I'm going to have to add 1 to each side. In this case, I find out that my b value is equal to 3, and I'm able to write my equation, y equals negative 1x plus 3. Because the 1 in front of any variable is an optional coefficient, you could also write this as y equals negative x plus 3. Either one of these is perfectly valid and a good way to write your final solution for a problem like this.